So hello everyone, this is lecture 41 for the mathematical physics. The last lecture we were discussing about some questions regarding the Cauchy integrals formula, and we were discussing here. So let me tell you one more thing. If you see this direct function and you need to find the points at which it is non-analytic, then put this z4 minus 1 equal to 0. Then you will get all these points plus iota, minus iota, plus 1, minus 1. Now see, contour is given as mod z equal to 0.9, so it is a circle of 0.9 radius. Now all these 4 points lying outside. So if this is the condition, then you will get again the integral equal to 0 using the Cauchy integral theorem. Okay. Now let's see one more kind of questions can also be asked. Means it's a open contour given. It is going from here and ending here. And you need to find the integral I equal to z square exponential z dz. Now see, this is the analytic function, but the contour is not closed, so you can't use the Cauchy integral theorem directly. So what you will do, you will make this contour closed and use the trick. Means you will take this limit plus this limit. Now the sum of these two limits will be equal to, the sum will be 0, because using the Cauchy integral theorem, because now it's a closed loop. So z square exponential z dz plus now this is on the real axis only, so we have y equal to 0, so dy will be 0, so we have z equal to x and dz equal to dx. So we will have minus 1 to 1 x square exponential x dx equal to 0. Now from here you can find this value, z square exponential z dz will be equal to minus of minus 1 to 1 this limit. So you know how to solve this using by parts. So I already told you how to do it fastly. First function, integration of second function, minus differentiation of first function, integration of second function. Now differentiation of first function and integration of second function, and again if you differentiate this, it will give you 0, so we will end here. So now you can use the limits minus 1 to 1, you will substitute here and you will get the answer 5 upon e minus e. So the value of this integral will be this. So main point to remember here is, if you are having an open contour, then make it close and use that theorem then. Okay, same you can see here also. If the contour is given something like this, so it is in anti-clockwise direction. Now to make it close, you will take this 1 to minus 1 line also, then this will be a closed contour. So again you can write this as exponential z dz plus 1 to minus 1 exponential x dx. This is real axis, that's why exponential x dx equal to 0. Now this sum will be equal to 0 because this is closed contour and this is a non-analytic, means it's analytic at all points, so we will use the Cauchy integral theorem and this closed contour will give you 0. Now from here you can just find this value will be minus of this, so you can solve this integration. Exponential x will give you exponential x, then putting the limits will give you e minus 1 minus e. Now see, if you divide by 2 and multiply with 2, then you will see it is a form of, first to multiply minus inside, you will get e minus 1 upon e, so it is e minus 1. So you can write this into this form. This is e plus 1 minus e minus 1 divided by 2 multiplied by 2. Now this is nothing but sine hyperbolic 1. Okay, so you know what is sine hyperbolic theta, it is e theta minus e minus theta divided by 2. So that's how you get this value. So this will be your answer. Now today what we will study is new thing, that is Cauchy integral derivative formula. So if something is given, means how to find the derivative. So if fz naught is equal to 1 upon 2 pi I fz divided by z minus z naught dz, means if you have this kind of form, remember this is formula applicable only on this kind of form. When you are having something like this, then f dash z naught will be given by 1 upon 2 pi iota fz divided by z minus z naught square. Okay, means if it is first derivative it will be square, if it is second order derivative it will be cube here, if it is nth derivative it will be n plus 1. Now see how is this formula very much useful. If you are not having z minus z naught only, now you are getting some power 3, 4, 5, then now you can find this integral using the differentiation. Means this 2 pi iota will go here divided by n factorial, so you can find this value of integral, which you can't find directly from the Cauchy integral formula. Now you can find using this derivative formula. How? Let's see some example. You need to find this integral sine square z divided by z minus a 4 dz. Now contour is given, it is an n circle, means it is contour which encircle a, means a is inside the contour. So this is not our, means what is the fz? Fz is, that is analytic at all points, so this will be your fz, and z equal to a will be z naught. Now see, this is power 4. So if you write it in the form of n plus 1, then n will be 3 here. So if n is 3, then this integral will be equal to 2 pi iota divided by n factorial. So 2 pi iota divided by 3 factorial, multiply n is 3, so I have third order derivative of z naught, and z naught is what? A. So just you need to solve this and you will get the value of this integral. So sine square z, differentiate this 3 times, you will get minus 4 sine 2a. Okay, because z equal to z naught is nothing but a. So after substituting in place of z, you will get this minus 4 sine 2a. So this will be your value of this integral. That's how you can use this formula to solve the integral. Now let's see some more examples. Now this is given, you need to solve this. So if you place n plus 1, then it will be n will be 1 here. So again 2 pi iota divided by n factorial. So 2 pi iota divided by n will be 1. Then you will use this, means it will be first order derivative because n is 1. So first order derivative of fz is cos z, because contour is given containing the point pi iota. So z naught will be pi iota, fz will be cos z. Then use this formula, this one, 2 pi iota will be this side divided by n factorial. So this integral will be given by this formula. So you will find the answer as 2 pi sine h pi. Okay, and in the somewhere you will use this formula also inside this solving this example. Sine I pi is nothing but I sine hyperbolic pi. Okay, we already proved this. Now just you can use this here. Now let's see how to solve this question. Integral is closed contour z4 minus 3z square plus 6 divided by z plus iota q dz, and c is enclosing minus iota. So our minus iota is inside the contour. So fz will be this numerator, and n plus 1 equal to 3, so n will be 2. So again use the same formula, 2 pi iota divided by n factorial, and n is 2, so we will find the second order derivative of this, and in the last you will put in place of z I. So you will get second order derivative is this, then multiply 2 pi iota divided by 2. So it will be minus 18 pi iota. This will be your answer. Now let's see one more question. Exponential z divided by z minus square plus 4 dz, and contour is 1 lies inside and plus minus 2 iota lies outside. So this is non-analytic at z equal to 1 and z equal to plus minus 2 iota, but these 2 points lying outside. So this function will be analytic. So this will be fz, your fz, and this will be your, means now n plus 1 will be 2, so n will give you 1. So again 2 pi iota divided by n factorial, multiply f1, n is 1 here, so you will find the first order derivative of this fz. So fz is this, first order derivative will be this. Then use the formula again, 2 pi iota divided by n factorial, multiply f dash 1, you will get your answer this. So that's how you can solve. These are very easy questions, means if you know the concept then they will be very easy. Now if you need to solve this, so first you need to convert it into the form in which we are using the Cauchy derivative formula. So first you will take the 4 common from here, you will get z minus pi iota divided by 4, and 4 cube will give you 1 upon 64 outside. So now to solve this integral, means mod z equal to 1 means it is a circle of unit radius, and pi by 4 is lying inside the radius, okay, inside the circle. So this will be your fz, exponential 3z, and n plus 1 equal to 3, so n will be 2. So you will need to find the second order derivative of exponential 3z, and then you will put in place of z pi iota by 4. So this is the simple this integral you need to solve. Then at z equal to pi by 4 you will get this value, and this will be your answer. So that's it for today. Just revisit these formulas of all Cauchy integral formula, Cauchy integral theorem, and this derivative formula. They are very helpful from the exam point of view. In the next lecture, we'll see about the Taylor expansion. That's it. Okay. Thank you, everyone.